Number 15 here, the directions are telling you two things that they probably didn't need to say. It says to use separation of variables to find the general solution to this differential equation. Well, they don't need to tell you to use separation of variables because you always have to separate your variables. So thanks for the reminder, guys. The other thing is that they're telling us to find a general solution. The only thing you could ever find besides a general solution would be a specific solution, but for that to fly, they'd have to give you a specific ordered pair, like for example, y of 5 is equal to 6. You would need something like this in order to be able to solve for C and find a specific solution. But they didn't give us that. I'm just making stuff up. So a general solution is the best that we can do. Okay, the first thing I'd have you guys do is to remember here that y prime should probably be written, now almost definitely be written as dy dx. Then, anytime you see addition or subtraction, that's a rough thing to deal with. Even though it sounds easier than multiplication and division, it's not. So what we're going to do is take this whole other term here and just bring it to the right side. So we're going to get dy dx is equal to the opposite of x squared multiplied by y. And now, to get all the y's on both sides, all the y's and the dy on the left, and all the x's and the dx on the right, we're going to do some multiplication by a fraction. I need to move that y that's over here on the right side, so I'm going to divide by y on both sides. The other thing I need to move is this dx that's on the bottom of the left, so we're going to multiply both sides by dx. So what's going to happen? This y on the right cancels with this y on the bottom right. The dx on the top left and that dx on the bottom there, they cancel each other out, and that should do what we need it to do. I'm going to write this as 1 over y dy rather than dy over y. I just think it looks better this way. And on the right side, we've got the opposite of x squared multiplied by a dx. So there's our separation of variables. All the y's and the dy on the left, all the x's and the dx on the right. So now we're ready to go ahead and anti-differentiate both sides of the equation. This is one I'm hoping you guys have memorized and you recognize it quickly. Antiderivative of 1 over y is going to be the natural log, but don't forget the absolute value of y there. And that equals, all right guys, we have the opposite of x squared. So that's going to become an x cubed when we raise the power by 1 and then divide by that new power. That'll be a negative 1/3 out in front of that. And this is where we put a plus c here. And if they had given you an initial condition, this is where I would probably switch to green and solve for c. But that's not what's going on right here. We just need to get y by itself. First thing we need to get rid of is the natural log, and we do that by exponentiating both sides. And remember, guys, you cannot do this. You don't exponentiate term by term, you exponentiate side by side. So that entire binomial expression there is your exponent on e. The e and the natural log on the left cancel each other out, so we're going to get the absolute value of y is equal to. Now, I certainly could write this just the way it's written, as e to the negative 1/3 x cubed plus c. That is not wrong, and that'll be fine, and it'll get you full credit. But one thing that I've seen a lot of people writing solutions here will do, whether it's for the textbook or whether it's on the AP test, they're going to take advantage of this little fact here that hopefully we all know and love, that a to the m power multiplied by a to the n power becomes a to the m plus n power. They're going to apply that property very often in reverse right here. They're going to go from this, all right, a monomial with a sum for its exponent, and they're going to break it up into something like this. So we could write this, we don't have to, but we could write this as e to the negative 1/3 x cubed power multiplied by e to the c power. And the allure of doing that, the reason that I think a lot of people who write solutions for calculus problems like to do it, is because of the fact that e to a c power. Remember guys, e is a constant and so is a c. A constant to a constant just becomes another constant. So I want to keep stressing over and over again, you don't have to do it this way, but very often you're going to see it written like this, that the absolute value of y is equal to, okay guys, we're going to have an e to the negative 1/3 x cubed power, and this just becomes another big constant that very often they like to put out in front of the e, and very often they'll use that as a capital C. And I've sometimes seen the letter K used there as well. All of that is just notational shenanigans right here. None of it has to be done that way, but if you ever see this capital C used as a coefficient very often in front of an e, that's usually where it came from. The only thing we would have left to do, guys, is to get rid of the absolute value. And you get rid of an absolute value by putting a plus or minus in front of the other side of the equation. C times e to the negative 1/3 x cubed, and that's what we've got. But the funny thing about this is we're not declaring what the value of c is. It's just some arbitrary constant, and that constant can be either positive or negative all on its own. So for that reason, we don't need that plus or minus in front of that c, because it's understood that the constant value c could make this thing positive or negative anyhow. So that, everybody, is probably the best answer here to problem number 15. And as I take a look at the solutions manual, they've got it written there. Oh, they went the other way with it. They did not split that up right there. Oh, got it. There it is. C, capital C, times e to the negative x cubed over 3. Yep, they've got the same thing that we do. So there's more than one way to skin that cat, everybody. There's more than one way to write that final answer, but I think that's one that you're likely to see down the road. So I just want you guys to get familiar with that format as we move forward.